Second video in our Tools of Chemistry unit is on the SI system, its prefixes, and how this applies to dimensional analysis. Taking a look at our learning standards and targets here, we are working on the essential standard. I can use proportional reasoning through the use of dimensional analysis to solve problems. In the previous lesson, we looked at those first and third learning targets, an introduction to dimensional analysis, and how we use those conversion factors to do that. Today we will start looking at the SI system and the prefixes that go along with it and how we use those to convert units. So the SI system, the abbreviation SI, stands for the International System of Units, and this International System of Units is the basis for all measurement in the world of science. It consists of 7 base units. Some of these units you are quite familiar with, others you've probably never heard of. Here is a list of those base units and the quantities they measure. You do not need to memorize these for any reason, but a couple that you are probably familiar with would be, for example, the meter, which we know is a unit of length. That is the base unit for the quantity length. The kilogram is the base unit for mass. Second, the base unit for time. Those you've certainly heard of. Perhaps you've heard of the unit Kelvin to measure temperature, maybe not. The ampere, I'm guessing many of you have heard of. Typically we just call it an amp, the number of amps of electric current. And then a couple you maybe have never heard of before, the mole, which is something we will study in great depth in this class later on in the semester. That's for amount of substance. And then the candela, which we really do not use in this class, for luminous intensity. Again, you don't need to memorize those, but those are the 7 base units of the SI system. What makes them base units is they all come from a physical constant in nature. In other words, there is something that occurs in nature that we can measure that is constant, meaning these units do not change ever. For example, the easiest one to understand is the meter. The meter is defined based on the speed of light. The speed of light is an absolute constant in nature. In a vacuum, light travels at roughly 300 million meters per second. 1 meter is defined then as the distance light travels in roughly 1/300 millionth of a second. It's not exactly that. It's like 1/299,800 something thousandth of a second. But the point is all 7 of these have a physical constant by which they are defined, so they can never change. Now, obviously, we measure a lot of things that don't use these 7 units, or at least they might not look like they use these 7 units. There are all sorts of other units that we use that come from or are based on these 7 base units. And here is a picture that gives us an idea of what we mean by that. Now, this image looks very busy. It might be a little difficult to understand at first, but I'll just point out a couple things here. For example, if we want to measure the area of something, we would measure that in square meters. So it would be the base unit meter times meters to give us meters squared. We would call that a derived unit. Likewise, if we wanted to measure velocity, that's a combination of our base unit for length, the meter, and for time, the second, because it's meters divided by seconds. And notice we can continue to use these units that you see here to find others. And what you're seeing here is just a very small portion of the number of units that we can derive from our 7 SI base units. Those base units themselves, while they are useful to know, in and of itself doesn't do a whole lot for us. What we're more interested in at this point are the use of SI prefixes. The base units, they're not always appropriately sized for a measurement that we might take. For example, if we wanted to measure the length or the width of our fingernail, while the SI base unit is in meters, the width of our fingernail would not be very easily measured in meters because it's just way too large. So we use prefixes combined with the unit in order to change the size of the unit. We can make it larger or we can make it smaller. You are already familiar with some of these prefixes that we use in the SI system. One of them is kilo, for example, a kilometer. The prefix kilo means 1,000. So for example, 1 kilometer or 1 kilometer is equal to 1,000 meters because the prefix kilo means 1,000. So 1 kilometer would be 1,000 meters. Or if you want to write it differently, you can say 1 meter is 1,000th of a kilometer because there are 1,000 of these in 1 kilometer. So take 1,000th of a kilometer to be 1 meter. Another prefix you are probably familiar with is the prefix centi. And the prefix centi means 1/100th. So in other words, if I had 1 centigram, that would be 1/100th of a gram, 0.01 grams. So notice this doesn't just apply to meters. Oftentimes students think, well, I know if I've heard of kilometers, I've heard of centimeters, but I've never heard of centigrams before. Well, the prefixes don't change based on what unit you have. We often associate them using the prefixes with a unit of length, the meter, but we can use it with any SI unit. And so we can see here that 1 centigram is 1,000th of a gram, or in other words, we could say 1 gram would be 100 centigrams, because centi is 1/100th of a gram. So 1 gram would be 100 centigrams. And then the final one that you're probably quite familiar with, or at least you've heard of before, is the prefix milli. That means 1,000th. So if I had 1 milliliter, that would be 1,000th of a liter. Or another way I could write it would be 1 liter equals 1,000 milliliters, because it would take 1,000 of those parts to equal the whole of the liter. Now there are lots of other SI prefixes. You do not need to memorize this whole list that you see here. Most of these are prefixes that we would rarely ever use in this class, or frankly many other classes. The ones that you really need to know, meaning have memorized, are these 3 that we put up here. Any others that you might come across, you would be given something like you see here. Like for example, if we saw the prefix giga, we can see giga means 1 billion, which would be 10 to the 9th. Or the prefix pico, that is 1 trillionth, which is 10 to the negative 12th. And you can see the very large range going all the way from 10 to the negative 18th, a super tiny prefix, the prefix atto, up to 10 to the 18th, the prefix exa, very, very large. So let's take a look at how we might use these prefixes to do some conversions with dimensional analysis like we're looking at in the last video. So here's a question. How many fluid ounces are in a 0.85 liter container? And I tell you that there are 29.57 milliliters in a fluid ounce. So if we consider the question, we're asked to find the number of fluid ounces. So how many fluid ounces are equal to 0.85 liters? Well, I give you this equality, 1 fluid ounce equals 29.57 milliliters. But notice we're asked about liters. In other words, I need to be able to convert between milliliters and liters. Well, thinking about our prefix milli, I can see milli is 1,000th. Now this is one that you will want to have memorized. So hopefully after a couple days you won't have to look that up. Or I could think of it as 10 to the negative 3rd. So in other words, 1 milliliter is 1,000th of a liter, 0.001 liters. Or many folks would prefer to write it without a decimal, numbers larger than 1. So 1 liter then would be 1,000 milliliters. So I can use that equality as a conversion factor to convert between liters and milliliters. So performing my problem here, I'm starting with my 0.85 liters. I need to cancel that unit liters, so I want to use this second conversion factor I have here. Either one of these would work just fine. I'm going to choose to use the one that has the larger number, the 1,000 milliliters in 1 liter. Notice the liters cancel. And now I can use this first equality I have here to cancel my milliliters. There are 29.57 milliliters in 1 fluid ounce. Notice based on where I put those units that I'll get my units to cancel. And I'm left with fluid ounces, which is what I'm looking for. And then plugging in my calculator, I get 29 fluid ounces for a container that is 0.85 liters in volume. So let's look at another question here. Determine the number of megameters, okay, the capital M. You go over here to our table here, I can see that's the prefix for mega. Determine the number of megameters in 2.65 times 10 to the 5th nanometers. You can see the prefix there, lowercase letter n for nano. And you can look at the sizes of those prefixes. Mega means 1 million, or 10 to the 6th. Nano is 1 billionth, or 10 to the negative 9th. So let's think about how we would do this. So here's what we're asked to find. How many megameters are there in 2.65 times 10 to the 5th nanometers? Well, from my table here, I can see a megameter is 10 to the 6th meters. You will notice oftentimes with these SI prefixes that it's most convenient typically to think of it in the scientific notation or the exponential notation, just because it's a lot easier to write instead of having all those zeros. And then a nanometer is 10 to the negative 9th meters, or a billionth of a meter. Now we could do this in two conversion factors where I convert from nanometers into meters using this equality here, and then from meters into megameters using this one. You could certainly do that, and there would be absolutely nothing wrong with it. But a more efficient way to do it is to just look at the difference in the sizes of these prefixes. I can see a megameter is 10 to the 6th meters, or a nanometer is 10 to the negative 9th meters. So there are 15 powers of 10. 15 powers of 10 that separate those two prefixes, or those two units. I get that because from 6 to the number negative 9, in other words 6 minus a negative 9, that's 15. So a megameter is 15 powers of 10 larger, in other words 10 to the 15th times larger than a nanometer. So that is my equality, my conversion factor. 1 megameter is 10 to the 15th nanometers. So I can use that as my conversion factor here, and I can do it simply in one conversion. So looking that I need here to cancel nanometers, I'll put my 10 to the 15th nanometers in the denominator, and that will cancel the unit nanometers. I'm left with megameters, which is exactly what I'm looking for, and I have an answer. So to summarize how I got this, I know this is probably a bit confusing the first time you're seeing this. All I did to get this conversion factor here is I looked up the value of each of the prefixes. The prefix mega is 10 to the 6th. The prefix nano is 10 to the negative 9th. And again, I just get that from my chart over here. And you don't need to memorize those. You'll have a chart to use in a situation like this, or I might just give it to you as part of the problem. And then you just ask yourself, how many powers of 10 separate those two? In other words, if you had a number line, what's the distance between 6 and negative 9? Well, that's 15. So that's how I get 10 to the 15th nanometers equals a megameter. Alright, here's a practice problem. As I mentioned in the last video, it is best used to read the problem, try it yourself. Once you've paused the video, try it yourself. If you get stuck, play the video, and certainly if you can work it all the way through, go ahead and do that, and then play the video and see how your work matches mine. So our question here, the average distance from the Earth to the Moon is 239,000 miles. What is this distance in kilometers? And I give you a couple of conversion factors here, or equalities. 5,200, that should say 5,280 feet, excuse me. Typo there, 5,280 feet should equal 1 mile. And then the second one here, 2.54 centimeters equals 1 inch. You might be wondering why I give you those conversion factors. Well, the reason is this. Anytime we are converting units of length from the metric system, like would be kilometers here, to the imperial system, or you might call it the American standard system, like miles, anytime we go from one system of measurement to the other, we always need to use this centimeters to inch conversion factor. The reason is that is the only exact conversion factor between those two systems of measurement. Any other conversion factor, any other equality, even if you had a whole bunch of decimal places, would be rounded. Like for example, you could look up the relationship between miles and kilometers, and you would see that 1 kilometer is roughly 6/10 of a mile. But that's not exact. Even if you had a lot of decimal places, 0.59 something miles, it would not be exact. So we always want to use this conversion factor here. So let's consider that as we work our problem. So we're asked how many kilometers are equal to 239,000 miles. Well, we just said we have to use this conversion factor here, centimeters to inches, meaning I need to get my mile unit to inches, and then I could use this conversion factor. Well, if I'm going to go miles to inches, I probably need to get it to feet first. So I'll use that conversion factor. Again, the typo up here should say 5,280 feet in a mile. So notice our miles unit cancel based on where I wrote those. So now I'm in feet. So now I can go from feet to inches. And as we know, there are 12 inches in a foot. And again, my feet unit cancel. And now that I'm in inches, now I can use this conversion factor, 2.54 centimeters in an inch. So I need my centimeters on top and inches on bottom so that my inches unit will cancel. And now that we're in centimeters, now we can convert to kilometers. Now this is just an SI prefix conversion. So based on what we saw in the last problem, we can just look at our size of our prefixes and figure out our conversion factor. So kilo means 1,000 or 10 to the third. So 1 kilometer would be 10 to the third meters. And then centi is 1/100th or 10 to the negative second. So a centimeter is 10 to the negative second meters. So ask yourself how many powers of 10 separate these two, between 10 to the third and 10 to the negative second. Well, the answer to that is 5. So 1 kilometer is 10 to the 5th centimeters. I know this because a kilometer is larger than a centimeter, so I need more centimeters, thus the 10 to the 5th centimeters compared to the 1 kilometer. So there's my conversion factor. Notice if I put my centimeters on bottom with the 10 to the 5th, the centimeters will cancel. And now my units work. I have kilometers. I was looking for kilometers. That's nice. Now I just need to plug this into my calculator. And if you do that, you will get 385,000 kilometers. A few review questions here. As each one pops up, please pause the video, answer it yourself, and then see how you did compared to my answer. Question 1. What is the purpose of a prefix in the SI system? Prefixes change the size of the unit. They either make the unit larger or smaller. Question 2. What is the value of the prefix centi, kilo, and milli? Recall, these are the ones that you do need to have memorized because we do use them quite often. A centi is 1/100th, or in decimal form, 0.01, or in exponential notation, 10 to the negative second. Kilo is 1,000, or 10 to the third in exponential notation. And milli is 1,000th, or 0.001, or 10 to the negative third in exponential notation. Question 3. How can you easily determine a conversion factor when only changing the SI prefix? So in other words, this is like if you were converting between megaliters and microliters. The only thing that's changing is the prefix. The unit itself stays the same, but you're just changing the size of the unit. So when you have those, if you simply determine how many powers of 10 separate the two prefixes, this will tell you how many times larger one unit is compared to the other. So in that example I gave you, a megaliter is 10 to the 6th liters, microliter is 10 to the negative 6 liters, so that would be 12 powers of 10, between 6 and negative 6. So your conversion factor would be 10 to the 12th microliters equals a megaliter. So looking at our learning targets here, we have looked at each of the learning targets for this essential standard of using proportional reasoning through the use of dimensional analysis. In this lesson, we looked at using the SI system and its prefixes to convert units.